Hi, my name is Miraz, and in this question, I'll explain how to determine if a given binary tree is a valid binary search tree or BST using a recursive approach. A binary search tree has one key rule. For every node, all the values in its left subtree must be smaller than the node value, and all the values in its right subtree must be greater. So, to check if a tree follows this rule, we need to verify that every node in the tree satisfies that condition, not just its immediate children, but the entire subtree as well. Recursive works perfectly here because a BST is naturally defined in terms of smaller trees. We start at the root and think in terms of valid ranges. The root can have any value. When we go to the left child, that child and everything below it must be less than the root's value. When we go to the right, everything must be greater than the root's value. Each time we move down the tree, we tighten these allowed value limits. If we ever find a node that breaks its limit, say a value in the left subtree that is larger than the root, we know immediately that it is not a valid BST. A recursive function would conceptually check if the current node is empty. If yes, that part of the tree is valid. Then check if the node value falls within its allowed range. Finally, call itself recursively for the left and the right subtrees, updating those range limits accordingly. If all nodes respect their limits, then the entire tree is a valid BST. This approach is efficient because each node is checked only once, giving it a time complexity or ON, and it chooses space proportionally to the height of the tree due to recursion. If it's a clean recursive solution that mirrors how we define a BST, each subtree must also be a valid BST. Thank you.